Lesson 2, Powers of 10. In this lesson, we will define the word exponent and base, explain the relationship between multiplication and division. We'll talk about moving the decimal and not adding a zero at the end, and some common 5th grade mistakes. So here we have a number, not what I meant to do. Here we have our number 10 to the 2nd power. This is how we call it. The exponent is that little 2 hanging on at the side there. And I'm going to try to move this down here. Yes, so that's closer. Yes, this is called the exponent. That's going to tell you how, well, the power of 10. If it's a power of 1, a power of 2, 3, 4, 10, whatever it might be, the exponent tells you what that is. And then the base is the big number. So B for big, B for base. So this essentially tells you that this is 10 to the power of 2, which means that if you were to write this in standard form, it would be 10 times 10, because it's to the power of 2. So there needs to be 2 tens. If it was 10 to the power of 3, it would look like this. 10 times 10 times 10 again. Okay? You may also see it written a little differently as well by doing the math. 10 times 10, if you know your doubles facts already, you know is, well, let me erase some things. I want to write it properly. 10 times 10 equals, let's get rid of this. $100. So you may see it written in 3 different ways. With the exponent written in an expansion, and then written, this is actually the standard form, 100. So there's 3 ways you might see it. Later on, we're going to use the exponent to help us multiply and divide by the powers of 10. Next thing we're going to talk about is the relationship between multiplication and division. They are something called inverse operations. So whatever multiplication does, division undoes it. And whatever division does, multiplication undoes it. I like to think of them as twin sisters who are having some sort of argument. One is sloppy, one is neat, one is kind, one is not so kind, maybe she's mean. They're just very opposite. Whatever one does, the other one doesn't like it. Okay, so that's just the relationship between multiplication and division. They do very similar things, but in the opposite direction. Now let's talk about this particular idea. Moving the decimal is what we are going to say in 5th grade. This is what we do in 5th grade. We do not say adding a 0. I'm going to use this example here of what you guys would like to say. So, 1 times 10 is 10, which makes sense. And then 2 times 10 is 20. 3 times 10 is 30. And you kind of get the idea. There's a pattern here. And a lot of 5th graders, when they start 5th grade, they still like to say, well, when I multiply by 10, I'm going to add a 0 at the end. I can just use the same number and add a 0 at the end. We are not allowed to say that anymore in 5th grade because it's not true. And I want to prove to you why it's not true all the time. While it was true for whole numbers, let's look at a decimal problem really quickly and prove why it's not true. Let's look at 7 tenths multiplied by 10. And I'm going to ask you the question right now before I begin. Do you think 7 tenths times 10 will end in a 0. If you're a 4th grader, you'll say yes, because that's what I was taught. That's what I noticed. Or something else. A 5th grader is going to know better. Watch this. When I multiply 7/10 by 10, that 7 is going to jump place value into the ones place. Or that decimal is going to move over 1 and cause the 7 to end up in the ones place. Either way, I'm going to erase the decimal here. Either way, the 7 is now 7 wholes, which is not what we expected if we were in 4th grade. 7 wholes does not have a 0 at the end. So we cannot keep saying that. In 5th grade, we must say when we multiply by 10, it moves the decimal. That is what's really going on. Even when we're working with whole numbers, even though we see it as zeros being, well, let's say the 0 is appearing at the end, that's because that decimal point is moving further and further away, making the number bigger. When we're multiplying, the decimal goes that way. And when we're dividing, those decimal points go in the opposite direction because they're inverse operations. They do the opposite. Let's put that into practice. First things first, let's make sure we understand what we're talking about. The model here, each grid represents one whole. Shade models A, B, C to match the number and decimals. So let's do that. I'm going to shade this in. Well, let's keep it small. Okay, model A says 2 wholes. Not 2 tens or thousands or 200, but 2 wholes. So I'm going to shade in 2 whole grids, because that's what 2 wholes look like. Let's make this a little bigger. See if that's better. Nope, that's not better at all. It's a little bit better. You get the idea. Shade in the whole thing. We need to shade in 2 of the holes to show 2 holes. Okay. This next one, model B, says 2 tenths. We're not going to shade in the whole thing this time. That wouldn't make sense. We're going to shade in 2 tenths. The last one is 200. What does that look like? It must be smaller. Look how far away that 2 is from the decimal point. Once you figure that out, you'll have finished the problem. Alright, so here we have, let's make that smaller again, a missing power of 10. So we're going to try to figure out how that decimal point moved and how many times it moved. Let me make this really small. Okay, let's see. No, smaller please. That should be good. So let's figure out how the decimal moves so that the decimal point is just in front of the 4. Let's figure out how many times it moved. Just once. So we're going to put 10. You can leave it just like that, because technically, if there's nothing there, it's the power of 1. But if you want to be clear, 10 to the power of 1. Let's do the same thing again for the next problem. Ooh, the decimal disappeared this time. Well, if you didn't know, you'll know now. All whole numbers have an invisible decimal. It's living right behind it. We just don't put it there because we're lazy. So we're going to figure out how the decimal got right behind the 4. So count with me. Let's see. 1, 2, 3 jumps it made. So that must be 10 to the power of 3. One last time, and then you'll do the rest on your own. Let's figure out how the decimal moved to be right in front of the 6. 1, 2. So that's 2 times. That's 10 to the power of 2. You keep doing what I did, and you'll be able to finish the problem. That's how you find out the missing power of 10. So here we see we're a little different. This is not going to have a power next to it. It's just a bunch of zeros. So we have 10, which is 10 to the power of 1. We have 100, which is 10 to the power of 2. And we see 1,000, which is 10 to the power of 3. And you can see the zeros match the exponent. See? 2 and 2. 1, 0, 1 power. So that's going to tell us how we're going to move our decimal. And remember, this is supposed to make the number smaller. It's division. Okay, it's going to decrease in value. So we're going to move it in the correct direction. Division moves this way, to the left. So let's move it one time, and it ends up right there. You're going to continue this problem on your own, because I gave you A. Move these decimal right here 2 times. And you're going to do the same thing for letter C. But remember, there is an invisible decimal right behind every whole number. So you can draw that decimal in and then move it. That's how you're going to complete this problem. On this next page, I'm going to show you some common 5th grade mistakes. Things I see students do all the time. Hopefully you won't make the same mistakes. So let's start with one problem here. The 5th grader knows that it's multiplying by the power of 2, because there's 2 zeros. Good for them. They figured that out. That's 10 to the power of 2. So they get started. They know that they should rewrite their number so they have so they have space to draw. Okay, so they're gonna draw that nice and big, maybe on a scrap piece of paper or the whiteboard. So they're gonna move their decimals 2 times. That seems easy enough. 1, 2. And I made an empty pocket. So the empty pocket needs a 0 in it. Let's make that look a little bit better. Did you spot my mistake? What's the mistake? I went the wrong way. This way is for division. And if you can see, this 8 got really small. It was supposed to get bigger. It was being multiplied by 10, so it should have gotten bigger. Instead, it got so small, I don't even know what to call this anymore. The correct answer was to go the other way. So I'm going to go the other way. 1, 2. And the decimal ended up right behind the 8. And now the 8 is sitting in the 1's place. The answer is actually 8 1s, or 8 wholes, which is plain 8. So a very common mistake is to go the wrong direction. Be very careful. Wrong direction. Alright, so I'm going to show you the other common mistake. Split my screen here. We have 80 divided by 1,000. Okay, 5th grader knows this should be 10 to the power of 3. I should move 3 times. Alright, and they rewrite their number so it's nice and big, and they figure out, okay, division means it's going to go that way. Okay. And the fifth grader says, I'm done, and the answer is 8/10. Did you find the mistake? If you said, I didn't move the correct amount of spots, or I didn't move my decimal enough, you're right. I was supposed to move it 3 times, not 2. So that is not the correct answer. 1, 2, 3. I made an empty pocket, so I'm going to put a 0 in it. And my brand new answer is 8/100. That is the correct answer. 80 divided by 1,000 will be 8/100. Very common mistake in 5th grade is not moving enough spaces, not moving your decimal enough times. So wrong direction and moving the wrong amount of times, making the correct amount of movements, very common mistakes. So I'm going to put that here. Correct. So horrible. Correct number of movements. That's often the issue. That is often the issue with 5th graders. Wrong direction and correct amount of movement. So if you find that you're getting a different answer than your friend or your mom or your dad, whoever it is you're working with, check those 2 things. Did I go the right direction? And did I make the right amount of movements? In lesson 2, powers of 10, we talked about the words exponent and base. We explained the relationship between multiplication and division. We talked about moving the decimal, not adding a 0, and some common 5th grade mistakes.